All right, guys, so as promised, here are the answers, just kind of a full run through of the practice test. So first one, if you guys are looking carefully at that picture, that's a right triangle. So when you're talking about, anything number 1 through 4, that is a right triangle. So they gave you kind of the generic picture. So remember, I would have to specifically say that something is a right triangle, or it would have to be mentioned that one of the angles is 90 or something like that. Then you can use SOHCAHTOA and you can use the Pythagorean theorem. So in the first one, we've got A equals 36 degrees and C equals 9. And remember, you always get for free that capital C is 90 degrees. So first thing that we can find is angle B. That's going to be the easiest one to find. We know that all sides of a triangle add up to 180 degrees. So we can start with, I'm going to clear this out. Start with 180, subtract 36 for A, subtract 90 for C, and that leaves us with 54 degrees for B. And then we can find one of the missing sides. So let's say that we decide to find little a first. Okay, so I will set up kind of our generic triangle here. They say that this is C, this is B, this is A. So this is little a, little c, and little b. So if we want this one, what they gave us was this angle right here and the hypotenuse. So with the opposite and the hypotenuse, you would set up sine. So you'd say the sine of 36 degrees, right here, is equal to the opposite side, which is A, over the hypotenuse, which is 9. So to get A by itself, all you have to do is multiply both sides by 9. So this will cancel. We'll get A by itself. I'm just going to plug this into my calculator. So 9 times the sine of 36 degrees. And we get that, about 5.3. And then finally, we will find this last side by using the Pythagorean theorem. So start with a squared plus b squared equals c squared. And I'm going to subtract this from both sides. Notice, it's like, since you have a calculator to use, you don't really have to do too much simplifying. Like, I could just plug this in. I can plug in 9 squared minus 5.3 squared. I don't have to find out what those values are first. So I get this, 52.91, that's b squared. And then to get b by itself, you would take the square root of both sides. So you can just do square root and then paste this value. We get about 7.3. Remember to read the directions. It says round sides to the nearest tenth and angles to the nearest degree. Okay, so number 2. We are given A equals 12 and angle A equals 58. So we can again find the last angle. The last angle we subtract away from 180. So we subtract away angle C because it's a right angle, and we subtract away angle A, and that leaves us with 32. 32 degrees. Okay, so now we are trying to find, I'll just get this sketch in again. So C, B, A, and then A, B, C. So we have this, now we have this. Let's find this first. Okay, so if we're trying to find B, you've got this one that you're looking for and this one that you have. So in relation to this angle, this is the opposite and this is the adjacent. So we could use tangent. Tangent of B. B is 32 degrees. Now, I will note right here, this is not the only correct way to do this. There are plenty of correct ways you could do this. B over little a, which is 12, and then just multiply both sides by 12. So this is very similar to what we did up above. So these 12s will cancel. We just plug this in. Okay, so we get about 7.5 for B. And then we can find C using the Pythagorean theorem. So a squared plus b squared equals c squared. Like I said, you don't need to simplify these two things individually. You can just plug this whole left side into your calculator. Okay, so we get about 200.25, and then you can just take the square root of that. So about 14.2. Okay, so we found this, and this. Okay, now number 3. Number 3, we have B is 85 degrees, and little b is 8. So we can find angle A. Angle A, if we already have 90 degrees and 85 degrees, we only have 5 degrees left. Okay, so now let's do a quick sketch. So we have B. We just found A, I'm sorry. Little c, little a, little b. So let's find this first. So in relation to this angle right here, A is the opposite and we have the adjacent, so that's going to be tangent again. Again, many ways that you could do this. Okay, so multiply both sides by 8. This will once again get plugged into the calculator. And this will be a small number. It should be a small number because it's a very small angle. So only about 0.7, very small little side length there. Okay, so little a is just 0.7. Very small angle will be across from a very small side. And then lastly for C, we do the Pythagorean theorem. A squared plus B squared equals C squared, so plug this in. We get this 64.49. And then square root both sides, and that will give us C. Okay, so about 8.03, which is really about 8 if we're going to round to the nearest tenth. Okay, so like 8.0. Okay, last one of these is number 4. Number 4 is a little different because we have all the side lengths, but we don't have any of the angles. So first thing we're going to do is find the last side using Pythagorean. Okay, so you can subtract 9 squared from both sides. Just like I said before, you don't have to simplify these. You can just plug this whole thing right into your calculator. 12 squared minus 9 squared. That's 63. So we get b squared equals 63. It's going to be just shy of 8 because 8 squared is 64. So we get 7.9. All right, so b is 7.9. So that's the first thing that we found. Now we need to find one of the angles. Doesn't matter which one. I say we go for A. So sine of A is equal to the opposite, which is A, so that's 9, over the hypotenuse, which is C, so that's 12. So this is the first time we've used inverse. If we're trying to find an angle and we have the measurements, what we do is we take the inverse sine. So let's say from here, if I took the inverse sine, remember the way these two work is they cancel each other out and you're left just with A. So we're going to plug this into the calculator. So if you hit that trig menu, the lower row is sine inverse. So we just plug 9 over 12 in there. Okay, so we get about 49. We would round up. Okay, so A is about 49 degrees. And then B is very easy to find. We just subtract everything from 180. So I start with 180, subtract my angle C, 90 degrees, subtract my angle A, and that leaves me with 41 for B. Okay, so those are all of your right triangle stuff. The next section, we are converting back and forth between radians and degrees. So start with 325 degrees. So to go from degrees into radians, you multiply by pi over 180, and then we're going to reduce down as much as you can. So I know they're both divisible by 5. So let's divide them both by 5. We get 65 here, and you get 36 here. And I think that's actually as far as you can take that. It is. Not the prettiest. But we get this. 65 over 36 actually does not reduce down any farther. Next one, also degrees, negative 175. Same thing, I'm going to multiply by pi over 180. If you're in degrees already, that's what you multiply by. Okay, so these also look divisible by 5, so let's reduce down. So I get negative 35. Okay, so this is negative 35 pi over 36. Okay, so almost negative pi, just a little teeny bit less. Okay, so now 7 and 8, we're going the other way. So we have 9 pi over 4. These ones we want to convert into degrees, so you multiply by the reciprocal, 180 over pi. It's easy to remember this because you're trying to cancel the pi's out. That's why you know it's 180 over pi rather than the other way. And then 180 divided by 4 leaves us with 45. Okay, so the denominators are gone. I'm just multiplying 9 times 45, and that gives me 405. Okay, and another one of these. Negative 5 pi over 6. Okay, I'm multiplying by 180 over pi because I'm in radians and I'm trying to get degrees. So the pi's will cancel. 180 divided by 6 leaves me with 30. And then I multiply negative 5 times 30. And that gives me negative 150. All right, so that's pretty straightforward as long as you remember what you're supposed to be multiplying by. Next section, number 9, we've got a couple pieces of this triangle here. Okay, so this, they did not mention anything about it being a right triangle, which means it is not a right triangle. Okay, always assume that unless you see the little square, that means it's a right angle, or if they tell you it is. So this one, we're going to start by doing the law of sines, because we have a pair. Anytime you have a pair of the angle and the opposite side, you do the law of sines. So we start with sine A over A equals sine B over B. What we're trying to find first is capital B. That will tell us what the first angle is, and we can use that information to find the rest. So we start by cross multiplying. So cross multiply here, we'll get 21 times the sine of 110 equals, and then cross multiply here, we get 16 times the sine of B. All right, next, divide by 16 on both sides. So these will cancel. Now I'm going to plug this into my calculator. Okay, so open a little fraction. I have 21 times the sine of 110, and then divided by 16. So I get this. And remember, you want to write down a bunch of decimals. So like 1.23335. Okay, so now this is just like what I did up here. If you're missing the angle, you do sine inverse. So I'm going to do sine inverse of both sides. So I will do sine inverse, and I'm just going to copy paste this. Okay? So undefined. Undefined is basically an error. That means there is no angle with that sign. And if there is no angle with that sign, that means there must be no triangle with these measurements that they mentioned. So if you get undefined or any sort of error like that, what that actually means is that you have no solution, which was one of the options that they offered you. It could have been that there's no solution. Okay? Let's move on to number 10 then. Next section. Find the exact value of each function. All right, so what I'm going to do here is I'm going to pull out my unit circle. Remember, you guys will have this on the test. So very important piece of this is being able to know how to use it. So yes, it will be provided for you, but you need to make sure you actually know how the unit circle is used. All right, so one of the first things that I want to point out, and this is super, super important, when you are looking at the unit circle, every single ordered pair that you see, the x value is the cosine, the y value is the sine. Okay, then we'll talk about how to do tangent, cotangent, cosecant, and secant as well. So the cosine of negative 90 degrees, first let's find negative 90 degrees. So I start at 0 and I go backward 90 degrees. So that's right here. You could also just do 360 minus 90 and you'd land at 270. And then look at the ordered pair. Remember, the x value is cosine, so the answer is 0. Number 11, we've got the sine of 585. Now I'm assuming you know that 585 is too big to be on the unit circle, so I will find a coterminal angle by subtracting 360. That's 225. So since 585 and 225 are coterminal, they have the same value of sine. So 225 is on my unit circle. It is right here. And remember, sine is the y value. So my answer is negative root 2 over 2. Okay, number 12, cotangent. Okay, cotangent. In section 12.3, we defined cotangent as being x over y. That is the formula for cotangent. Tangent is y over x. Very similar. They're reciprocals. So I go to 4 pi over 3. It's right here. The x value is negative 1/2, and the y value is negative root 3 over 2. So I'm just going to divide. So 1/2 divided by, negative 1/2 divided by negative root 3 over 2. And when I'm dividing fractions like that, what I do is I take the numerator and then multiply by the reciprocal of the denominator. Okay, so two things will cancel. The 2's will cancel, and the negatives will cancel. So I end up with 1 over the square root of 3. But you can't leave a square root in the denominator like that, so we do what we call rationalizing the denominator. Or I multiply by a fancy 1, and I get the square root of 3 in the numerator, and then root 3 times root 3 just leaves me with 3 in the denominator. Okay, so that's how you do cotangent. Number 13, I'll show you how you do secant. Okay, negative 9 pi over 4. 9 pi over 4 is, well, let's convert it first. Okay, so negative 9 pi over 4 is negative 2 pi, and then it's another negative pi over 4. Okay, because 8 pi over 4 would be 2 pi. So 8 pi over 4 would take me all the way back to start in the initial position here. And then I just want to go another pi over 4, which would land me right here. So let me do that in another way. So negative 9 pi over 4, going this much is a jump of pi over 4. So I go negative 1 pi over 4, negative 2 pi over 4, negative 3, negative 4, negative 5, negative 6 pi over 4, negative 7, negative 8 pi over 4, negative 9 pi over 4. Lands me right here. Okay, so that is in this location. Secant is the reciprocal of cosine. Okay, so cosine is root 2 over 2, because that's the x value. So secant would be the reciprocal, 2 over root 2. Okay, but remember, we can't leave a square root in the denominator, so we multiply top and bottom by root 2. So I get 2 root 2, and then in the denominator, root 2 times root 2 is 2. The 2's will cancel each other out, and I'm left with root 2 as my final answer. Okay, so I think the unit circle can go away for now. Let's look at this type. Tangent of cosine inverse of 4/5. Okay, so this is what I call the triangle problem. Cosine inverse is always going to be an angle. It's the angle that has a cosine of 4/5. So we want to draw a picture of that angle. Let's say this is that angle. If it has a cosine of 4/5, remember cosine is adjacent over hypotenuse, so the adjacent must be 4 and the hypotenuse must be 3. So in this situation, I'm still missing a piece. I need to find that missing side. So I do a squared plus 4 squared equals 5 squared. So I can subtract 4 squared from both sides. So I have 25 minus 16, which is 9. So that means that 8 is 3. This is actually something called a Pythagorean triple, so you could have known that it was a 3, 4, 5 triangle right from the beginning. Then we want to find the tangent of that angle. So the tangent of this angle, remember tangent is opposite over adjacent. So for tangent we get 3 over 4. So this is basically saying what's the tangent of the angle whose cosine is 4/5. So we find all the sides of that angle and then we take the tangent. Okay, 15, we've got arc cosine of 1/2. Now, arc cosine is the same as cosine inverse. You guys will have your unit circle for problems like this too. So arc cosine means what angle has a cosine of 1/2. So it's basically the same as trying to figure this out. So there's some mystery angle, we don't know what it is, but its cosine is 1/2. So remember cosine is the x value. So let's look for a cosine of 1/2. Here's one right here. And here's one right here. So both of these angles right here have a cosine of 1/2, 60 degrees and 300 degrees. However, we planned for that. you're not supposed to have two answers. You're only supposed to have one answer. So that's why they do what we call the domain restrictions in section 12.9. Cosine, we only give answers that fall in this top half, only from 0 to 180. So 300 does not fall in that restriction, so that means we only give this answer. So 60 or pi over 3. And again, you would have your unit circle to help you out with that too. Okay, number 16, terminal side of angle theta in standard position intersects the unit circle at this point. Okay, so this is something very straightforward once we're looking at the unit circle. Remember, every x value is the cosine, every y value is the sine. So when all they're looking for is the sine and cosine, it's very straightforward. Just remember, x goes with cosine, y goes with sine. Okay, 17 is the multiple choice question. It says, what angle has a tangent and sine that are both negative? Okay, so if you look at the four quadrants right here, we had the acronym ASTC. A stands for all. They are all positive in this quadrant. S stands for sine. Sine is positive in this quadrant, which means that cosine and tangent are negative. So it's not in this one, it's not in this one. In this one, tangent's negative. The reason tangent's negative is because sine and cosine, and this tangent is positive, tangent is positive, and that's because sine and cosine are both negative, so it's not this one. In this quadrant, cosine is positive, which means sine and tangent are both negative, so this is the quadrant that we want to be in. 65 degrees, not in that quadrant. 120 degrees, not in that quadrant. Neither is 265, but 310 is. 310 degrees falls into that quadrant that we need. Okay, 18. 18, we've got this one formula. It's 6,077 minus 31 times the cosine of 2 theta. Okay, it says theta is the latitude, and then it says find the length when the latitude is 120 degrees. So all we're doing is we're taking this formula that they gave us, and we're plugging in 120 degrees for theta. Okay, so this can just get plugged right into our calculator. I think people may have made this a little bit more difficult than it actually was. Okay, so we get this, 6,092.5. Okay, 19. 19, amplitude period. Okay, so that is our function right here. The amplitude and the period are the only things changing in these first two. So the amplitude is always the number that's right in front of the word sine or cosine. So here that's 2. The period, we've got a formula. Period, we take 360 degrees, which is the normal period, and then divide it by whatever number is in front of the theta. So 360 divided by 3 ends up being 120. So when I go to graph this, I don't have a new midline. My midline is just the theta axis because I don't have a vertical shift yet. I didn't move it up and I didn't move it down. And my period of 120, there's no phase shift, so I can just start marking right on the axis here. So my cycle will end at 120, which means it'll be halfway through at 60, a quarter of the way through at 30, and 3/4 of the way through at 90. And then my amplitude, I could go up 2 units, or I can go down 2 units. Okay, so last, a sine function starts at the midpoint, goes up to its high, back to mid, then to its low point, and finishes at the midpoint. So midpoint for point 1, up to the high point, down to the mid, down to the low point, and it finishes the cycle at the midpoint. So remember, make sure you're always graphing a little bit more than just what you needed to show that yes, those sine and cosine graphs do keep going, they're periodic, they repeat over and over and over again. Okay, number 20. Okay, so we're basically doing the same thing here. This time the amplitude is 1/2, so it's going to be kind of like a squished graph from what the original is. Period, same formula. We start with 360 degrees and then divide it by whatever number is attached to the theta. Here that's a 2. So we get 180. No vertical shift, no phase shift, just kind of a basic graph here. So here's theta. So if we say this is 1 and this is -1, we can only go halfway up to that point. No phase shift means I can start marking right on the axis. I finish my cycle at 180, which means I'll be halfway through at 90, quarter of the way through at 45, and 3/4 of the way through at 135. And don't forget 0 is your starting point. This time I'm doing a cosine graph. Cosine starts at its high point, back to the midline, low point, back to the midline, and then finishes the cycle at its high point. Okay, so it starts the cycle at its high point, which is actually only a 1/2, goes to the midline, down to its low, midline, and then finishes on the high point. So, very low little graph here. Okay, so that is our second graph. That is our cosine graph. So now let's look at this next multiple choice question that we have, number 21, and this is asking about the period of a cotangent function. So tangent and cotangent have a different period than secant and, than cosine and sine. For tangent and for cotangent, you actually take 180 and then divide 180 by whatever is in front of the theta. And here it's just a 1. So the period is just 180. So that would be letter G for multiple choice. Okay, handful more here. Number 22. We have a bunch of pieces here. We've got a triangle XYZ. Side Y is 15. Side Z is 9. And angle X, capital X, is 105 degrees. First determine whether it should be started with sines or cosines. Law of sines is probably the easier of the two, so you want to use that if you can. The only way you can use law of sines is if you have a pair. So I have side Y, but I don't have angle Y. I have side Z, but I don't have angle Z. And I have angle X, but I don't have side X. So I don't have any of the pairs, which means I cannot use law of sines first. I'll use it second, but first has to be law of cosines. Okay, so that's the first part of the question, was asking what you start with. And then the law of cosines, what I'm trying to find is side x. So I do x squared, and all these formulas are the same. It doesn't matter that the formulas I gave you have an a, a b, and a c. All the formulas are the same. So here's the side that you're looking for. You square the other two sides and add them together. Minus 2 times the other two sides, and then the cosine of the angle opposite to the side that you have. So that's your formula. We're just going to plug all this stuff in. So y squared plus z squared minus 2 times y times z times the cosine of x. Oops, not 110. Sorry about that. 105. Okay, so if you're solving for the side like this, plug this whole thing straight into your calculator. I had people that were trying to kind of simplify it down little by little, and they ended up making mistakes that way. So just plug this whole strand right in. 15 squared plus 9 squared minus 2 times 15 times 9 times the cosine, there it is, of 105. Okay, so we get that. 375, and then kind of keep all the decimal places. So x squared equals 375.88114. That's an x squared. Because you're trying to get x, you're going to finish it off by square rooting both sides. Sorry, we were interrupted by end of the week prayer. So plug in, we've got square root, and then you can just reach up and copy paste that. There we go. So x, remember, rounds to the nearest tenth, is about 19.4. And now we've got a pair. We have the pair of x's, so we can use law of sines. Okay, so you've got sine x over x equals, let's find y first. Doesn't really matter. Sine y over y. And then we've done this before. Now you cross multiply, so we do 15 times the sine of 105 equals 19.4 times the sine of y. Sorry, that should be a capital Y. And we're trying to get that capital Y by itself, so we divide both sides by 19.4. So that cancels here. I'm going to plug this left-hand side in. So 15 times the sine of 105, and then divided by 19.4. So remember, you want to keep kind of a bunch of those decimals. And then what you're going to do to get the angle is take inverse sine. So take inverse sine. I'm just going to copy paste this so I can get a super accurate answer. So y equals, we round to the nearest whole number. It's closer to 48 than it is to 49. And then my last angle is the easiest. So for angle Z, I know all triangles have 180. Angle X was 105, and angle Y is 48. So my remaining measurement is 27. Okay, last couple here. We've got a graph for number 23. Okay, so the only thing being affected here is just the phase shift. So my amplitude is still 1, just standard. My period is still 360 degrees. My phase shift, it moves everything to the left 180 degrees. Okay, so let's set up what the normal period would look like. You'd start at 0, you'd end at 360, the halfway point would be 180, quarter mark, and 3/4 mark. Okay, so all of those values are going to move 180 degrees to the left. Okay, so subtract 180 from all of those values. So you get this, and then subtract 180, you get 0. Subtract 180 here, you get 90. Subtract 180 here, you get 180. So we're going to use that to mark up the theta axis. Okay, so I am going to use, or I guess I probably should have, here let's squeeze some more in here because I have to go all the way to negative 180. So let's call that negative 180, negative 90, and this would be 0, of course, and then that's 90, and then that'll be 180. So really didn't need all this, probably should have used more room over here, sorry. The amplitude is just 1, so we're just going to go up 1 unit and then down to negative 1, and we've got the period. The period goes now from negative 180 up to 180, so it's still a period of 360. I just had a phase shift where I would have had everything right here, but I pushed it 180 degrees to the left. Okay, so remember cosine shape. Cosine goes from the high point to the midline to low to the midline and then finishes at its high point. So it's going to start right there at the high point, then to the midline, to its low point, midline, and then finish at the high point. So it'll look something like this. Okay, so that is that one cycle. So now, the only thing for some reason that they didn't have on the practice test was a vertical shift. So remember, the vertical shift would be like a little plus or minus something out on the end, like out here, and then it would just push the graph up or down a certain number of units. All right, so see, I did do one of those, or 2 of those, I think, on the review video that I posted. So check that if you remember having any trouble with the vertical shift while you were in section 12.8. Okay, 24 is a tangent graph, which, remember, tangent graphs could potentially pop up as bonus material, but will not pop up as regular material. Okay, so with our amplitude, so this 1/2 does not affect our amplitude. There is no amplitude to a tangent graph. Because remember, it goes on forever, up and down. We've got these vertical asymptotes. The tangent graph kind of wiggles like this, but it goes down forever and it goes up forever. Oops. What the 1/2 does is kind of like a compression. So normally the tangent graph does something like this. It might kind of compress and do something like that. Like that's really all that it's going to do, is it kind of takes the whole graph and like squishes it this way. Okay, so that's what that's going to do. It doesn't affect the amplitude when we're talking about tangent because there is no amplitude. What this does is it shifts it pi over 2 units to the right. The minus actually means it goes to the right. So our phase shift is going to be positive pi over 2. We're going pi over 2 to the right. If you consult your unit circle, or if you just have it memorized, you will know that pi over 2 is the same as 90 degrees, so it's going to go 90 degrees to the right. Okay, so let me write down a couple of things about tangent. Tangent, there are two things that are very important. We've got the x-intercepts, and we've got the asymptotes. Okay, so as of right now, no phase shift being applied. The x-intercepts are at 0, 180, 360, blah, blah, blah. It kind of follows the pattern like that. Okay, so the x-intercepts start at 0 and then they go every 180 degrees from that point on. And then the asymptotes are at negative 90, positive 90, 270, and they carry on that pattern. So the x-intercepts are every 180 degrees, the asymptotes are every 180 degrees, but the first x-intercept is 0, the first positive asymptote is 90. So they start at different places, but they both go every 180 degrees. Now, if I'm adding 90 degrees to everything, everything's going to get shifted over. So these are the new values. Okay, and then here are the new values here, 0. So it's basically like they get switched. Like what used to have x-intercepts, there's now an asymptote there. Where there used to be an asymptote, there's now an x-intercept there. So I will show you. Okay, so here's our theta axis, here's our y-axis. So we are going to have 90-degree increments. Okay, so x-intercepts are going to be every 180 degrees. They got pushed over. It used to be here, 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 but they got pushed over, which means there would actually also be one here. And then my asymptotes used to be here, 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 but they also got pushed over. So I have one here, here, here. I would have another one here. That would be at 540. So then the line itself, and let's draw it, this would be negative 180. I would have an asymptote there too. So the tangent line itself kind of skims along here. Because of the 1/2, that just means it's going to get closer to the x-axis before it turns around. So all of these shapes look the same. Just repeating the tangent shape just over and over again. Okay, now hopefully you can see the reason why we say there's no amplitude, because it goes on forever. Okay, so that is a sample tangent graph. We had a shift of 90 units to the right, which would actually look exactly the same as if you shifted it 90 units to the left. Fun fact. Okay, last one, number 25, we are creating our own equation. So a water wheel has a diameter of 20 feet. Okay, so the diameter is 20 feet, which means that the amplitude would actually be 10 feet. Okay, so the diameter is 20 feet, which means the amplitude is 10 feet. We know that because the diameter would be like from all the way to the top to all the way at the bottom. So if you only went halfway, which is what the waves do, the amplitude would be 10. It makes one complete revolution in 45 seconds. Okay, so 360, we need to know what B is to make it come out as 45. Okay, so we're going to multiply both sides by B, just like this. So then we get 360 equals 45b, and then we can divide both sides by 45. Okay, so these will cancel, and then what we get is 8. Okay, so 360 divided by 4 is 8. I'm sorry, divided by 45 is 8. So that's the number in front of the theta. So this is A. So in our formula, we've got A, we've got B. We also need H, and we need K. Okay, so H is the phase shift. They don't particularly mention anything moving left or right as you're reading through this particular story problem. So there is no phase shift. And then it says let the height at the top of the wheel represent the height at time 0. Okay, so let the height at the top of the wheel represent the height. So that means everything's actually getting pushed up 10 feet because you want the height to represent the starting point. So everything gets pushed up 10 feet, and they do kind of demonstrate that in the picture. All right, so we've got all of these values, and so it says write an equation. So if you want it to start up at the top of the graph, then you'd make that a cosine. Yeah, we'd make it cosine. Okay, so cosine looks like this. Okay, so let's plug in our information. Okay, so our equation looks like that. Equation looks like that, and then it says to graph the function. So I will show you that it actually does come out to make sense. Okay, so let's go 5, 10, 15, 20. Our baseline is now 10. So that's going to be kind of our starting point where it would revolve around. And then we've got 8, but we already know that it takes 45 seconds to complete one full cycle. So we can just automatically mark on 45. Halfway through that cycle would be 22.5. The quarter mark would be 11.25. And then the 3/4 mark here would be 33.75. Okay, nice neat values there. So we wanted to start off at the top. That's what a cosine graph does. So that's why we made it a cosine graph, because he said we wanted it to start up at the top. Let the height at the top of the wheel represent the height at time 0. Then cosine goes to its midline, then down to its low point. Point 4 is at the midline, and then it finishes off at the high point. Okay, so it's going to look something like this. So now one thing real quick, since time is, the start of time, we're not going to have negative time, my graph actually does start here. And then the wheel revolves over and over and over again, so it starts at the top, goes down to the bottom, goes up to the top, comes down to the bottom. So that is your graph, and this is the equation that matches with that graph. All right, so hopefully that is helpful. Good luck, study hard.